Old tires arrive in massive volumes, thousands per shift, each one carrying steel, fiber, and rubber locked together under pressure. They are unloaded into enclosed intake zones. No sorting by hand, no pauses. From this moment forward, everything moves by conveyor, because scale demands flow.
Batch 2023A012 is moving through.
Origin confirmed, city landfill. The flow rate is steady.
Old tires feed directly into twin-shaft shredders. These machines do not cut fast, they cut with torque. Rotating blades pull the tire inward, tearing rubber, steel, and fiber apart simultaneously. Heat is monitored. Excess friction destroys rubber quality. The output is controlled size tire shreds, no longer whole, but not yet usable. Tire shreds move under powerful magnetic separators. Steel belts and wire reinforcements snap free from rubber fragments. Magnets lift metal upward. Rubber drops downward. Recovered steel is compacted and sent to metal recycling. The rubber continues alone. Purity begins here. Rubber fragments enter secondary shredders. Blades reduce material further, producing uniform rubber chips. Particle size is monitored constantly.
Down the material
too large,
precise
and grinding becomes inefficient. Too small. Heat builds too fast. Control protects downstream quality. Rubber chips pass through air-based separation systems. Lightweight nylon and polyester fibers lift away. Heavier rubber falls through. This step removes the last structural contaminants. What remains is almost pure rubber, ready for precision size reduction.
The classifier uses a powerful vortex to separate the materials. Lighter fibers are drawn up, while the heavier rubber chips fall away.
The glycophyll separate system is evident here.
Clean rubber chips enter grinding mills. Ambient crack mills fracture rubber mechanically. No freezing, no chemicals. The result is crumb rubber, angular particles engineered for asphalt bonding. Particle shape matters as much as size.
The system detects oversized crumb rubber, diverting it back into the grinder for reprocessing, ensuring maximum efficiency.
Sàng dung nhiều tầng, hoạt động không ngừng, biến đổi vật liệu thô thành các kích cỡ chính xác.
Quá trình phân tách chính xác này cho phép cao su vụn mịn đi qua, giữ lại các hạt lớn
Crumb
hơn
rubber
để
flows
xử lý
across
tiếp.
vibrating screens. Multiple decks separate particles by size. Only rubber within strict size tolerances advances. Oversized material is recycled back to grinding. Uniformity here determines pavement performance later.
This is the reject fraction, oversized crumb rubber being carried away. The closed-loop system ensures that nothing goes to waste, sending it back for fine grinding.
Approved crumb rubber enters sealed silos. Moisture is controlled. Feed rates are calibrated. From here on, rubber becomes an ingredient, not a waste product. Meanwhile, asphalt binder heats in insulated tanks. Temperature determines viscosity. Viscosity determines success. Too cool, rubber won't react. Too hot, asphalt degrades. Everything must align before mixing begins.
Quy mô khổng lồ của hoạt động thể hiện rõ qua dãy bể chứa nhựa đường, cho thấy số lượng lớn cần thiết cho quá trình pha trộn.
The powerful high-shear mixer transforms the raw materials, aggressively blending the crumb rubber into the viscous asphalt binder.
Crumb rubber feeds into high-shear mixers. Hot asphalt envelopes the particles. Rubber begins to soften, to swell, to absorb oil from the binder. This is the moment rubberized asphalt is born. Mixing speed, temperature, and time are tightly controlled. The blend is held under heat. Rubber particles expand internally. They integrate into the asphalt matrix. This digestion phase creates elasticity, the defining property of rubberized asphalt.
The agitator
Too short
arm
and
ensures
performance
complete
suffers.
homogeneity
Too
during
long
the critical
and structure
swelling phase,
collapses.
preventing
Timing is
settling of
everything.
the viscous biomass.
Technicians monitor viscosity and elasticity in real time. Samples are pulled. Data is compared to road grade specifications. If values drift, parameters adjust immediately. No batch moves forward unchecked.
The tensile strength is within tolerance, but the thermal conductivity is slightly off.
Let's rerun the thermal scan on the secondary sample.
The rubberized asphalt, combined
Some
with
blends
specialized
require
additives
modification.
at the dosing area,
Polymers improve
flows towards the
flexibility.
homogenization
Stabilizers
tank.
extend temperature tolerance. Additives are introduced precisely, never blindly. Each region demands different performance.
The wide-angle view reveals the flawless integration of the materials. This uniformity confirms the superior... The perfectly uniform, dark, viscous surface ensures a stable and high-quality product.
finished blend is mixed continuously. No separation, no settling. This ensures consistency from the first load to the last. The material is now road ready.
The flow rate is stabilizing at 50%.
Acknowledged. Maintaining pressure differential.
Rubberized asphalt pumps into insulated tanker trucks. Temperature is maintained, contamination is avoided. What leaves the factory must arrive ready to pave. Throughout the process, air systems capture fumes. Filters remove
just a
particulates.
word.
Odor
It's a
control
commitment
protects surrounding
etched in
areas.
steel.
Safety isn't optional. It's engineered into the system.
The core reactors stabilize the raw materials at this junction.
And the byproduct is immediately recycled back into the system.
What began as discarded tires now becomes infrastructure. Old rubber transforms into quieter roads, longer pavement life, and reduced waste. This factory doesn't just recycle material, it redesigns it at industrial scale.